Hello dear students, welcome to Pen and Paper Chemistry. Our topic for this video is the properties of haloarenes and we are continuing with part 3. We have already discussed why haloarenes are less reactive towards nucleophilic substitution. We've also spoken about ortho meta para. If you have missed any of this, you will find this in the previous 2 videos. Oh, what does it say? A teacher is effective only when the student is receptive. What does this mean? Yes, boss, you need to get your pen and paper out in order to derive maximum benefit from this video. That's what it says. Unless and until you write the reactions with me, you will still be struggling even by the end of this video. So quickly grab your pen and paper and ready, steady, go for the next lesson of haloarenes. Now if you recall, I've been giving you flow charts which are easy to remember, and this is the basic outline of it, and this is what we did in the last lesson. We are now going to move on to the next set of reactions. And before we do that, I will give you an overview of what you can expect by the end of part 4. This is the complete overview of the flow chart. The reactions are not complete. The products have not been completely listed over here. Okay, we are yet to do that. So this will give you an idea about the size of the paper you have to take in order to get the complete flow chart at a glance, right? Okay, what are we going to do today? The nucleophilic substitution reactions of haloarenes, right? This is the part where we are going to talk about this set of reactions, right? 3 nucleophilic substitution reactions we are going to talk about. Why only 3? And if you notice, each of these reactions, the conditions are quite strong. 623 Kelvin, right? 300 atmospheric pressure. Same way, when you talk about reaction with aqueous ammonia, look at the temperature, pressure conditions. Then the same is replacement with the cyano group, right? All these are extreme conditions because nucleophilic substitution reactions are difficult. What are we talking about in the nucleophilic substitution reactions? So you have the benzene ring and you have the halogen over here. When we are talking about nucleophilic substitution, what we are saying over here is that the nucleophile X halogen will be replaced by another atom or group which is again a nucleophile. That's what we mean by nucleophilic substitution reactions. Now this replacement becomes difficult. We have already discussed the nitty-gritties of it in part 1. Request you to visit that video in case you want to understand it deeper. Nucleophilic substitution, 3 categories we are going to do over here. First reaction, replacement by the OH group. So replace it by the OH group means the halogen. So what I'm going to do over here is I am taking the starting haloarene, can be a chlorobenzene or a bromobenzene, the most commonly studied haloarenes. So the halogen gets replaced by the nucleophile. Now here what happens is we are taking a 6 to 8% solution of aqueous NaOH. So first step of this reaction that we get is a sodium phenooxide, ONA. It doesn't get easily replaced by the OH group. This then is further hydrolyzed in order to give you the product. Sodium phenooxide. For you, you can go on writing the reactions. I am writing the products in the flow chart that we have drawn, and there we go. We have OH over here giving us what we call as phenol. Now, most of us are used to writing the benzene structure like this. Don't worry, you write it like that. Write the reaction conditions, write temperature, write pressure, write catalyst, and then you write the product. It's one and the same thing. So we have in the first step ONA. This on acid hydrolysis. Acid hydrolysis, we are treating it with dilute HCl, and so we have ONA. This gets hydrolyzed to give you OH, which is phenol. Both the structures are same. There's no difference. It's just that when we do it online, when we do it digitally, this looks more easy and presentable, right? So since we are used to writing it by hand like this, that's why I'm showing the reactions over here, right? This reaction is the basis for the Dow's process in order to manufacture phenol, right? Have you written this reaction? Let's go on to the next one. So what we are treating it with is, we are treating it with aqueous ammonia. So here my nucleophile is NH2, right? So it replaces the halogen by the NH2 group, correct? This is aniline. We are introducing new aromatic compounds to you at this point of time, and we will have cuprous chloride and water as the side product. Now this reaction can also, or this product can also be obtained when we react the haloarene with sodamide in liquid ammonia at a temperature of 196 Kelvin. So let's get going and let's write down the reaction for this one. So again, we take the chlorobenzene, bromobenzene, anything you can take, write down. There are two possible reactions, 1 and 2. One is with aqueous ammonia, the other is sodamide in liquid ammonia. Please go ahead, write the two reactions separately. Write the reaction conditions once, because when there is coordination between the hand and the mind, you tend to remember it better. Right, so we will have NH2 group over here, and that gives us aniline. Would you like to try the third nucleophilic reaction yourself? That is reaction with anhydrous cuprous cyanide, 470 Kelvin in the presence, or using pyridine or quinoline as a solvent. Go ahead. So what will be the nucleophile over here? Absolutely right. So we will have CN over here, right? Don't worry, it's the same thing. What I have done over here is, instead of writing the CN there, I have put it here. Yes, you can put it like this also. Now, don't you think that we can connect it to what we did in haloalkanes? By the way, first write down the reaction for this one. We are not proceeding till you've written the reaction for this one. Go ahead. I'm waiting for you to complete it. Right. It'll do you good. You will be happy and smiling at the end of this lesson. Write the condition over here. What type of copper cyanide are you taking? You've got CN. Now, if you remember, in haloalkanes also, we extended this reaction further, right? Oh my God, there's something hiding behind the... Yes, there's. We need to find out what it is, right? Would you like to know? Would you like to recall first before I reveal what is hiding behind the scenes? Would you like to try and recollect what we did in haloalkanes under this? Remember, there was something to do with reduction, hydrolysis, partial hydrolysis and complete hydrolysis. Yes, if you've revised it, you'll be able to know and you will be able to write the reactions before I tell them to you here. There you go. So we have reduction. Cyanides, when they will undergo reduction, what will happen? Yes, the CN groups, C triple bond N gets reduced. So we'll have H, H, and then an H, and then an H. So the pi bonds break and we will have CH2NH2. Please write down the name of this compound for me. Okay. Next, we've got partial hydrolysis with concentrated HCl. There was one more reagent we spoke about when we did haloalkanes. Complete that over here. Partial hydrolysis means C triple bond N. Hydrolysis means water, O and H2 over here. So what do you get over here? Yes, it's an amide, CONH2. If you are finding it difficult writing the structures like this and you want to write the complete reaction, this is how we are going to do it. There we go. So we formed CN, then we've got reduction. Write the conditions. It's LAH, stands for lithium aluminium hydride, or you use hydrogen in the presence of nickel, or you can use sodium and ethanol as the reducing agent. So in this reaction, write all the three possible reducing agents that you can use. And there we go. We have the product CH2NH2, right? Similarly, partial hydrolysis. Have you written this one down? Go ahead. Now we are going to write partial hydrolysis and the two conditions and the product over here. So what will be the product over here? CONH2. So this is our partial hydrolysis. One molecule of water you're going to add to this compound. But what if it says complete hydrolysis? So that means add one more molecule of water. So what I am going to do is, let me split it here. So I have H and OH. What does it sound like? Does it look something familiar? Yes, you got it. It's benzoic acid. Superb. That's good. That's great going. So we get over here complete hydrolysis. If you want, you can write the reaction in 2 steps, or you can write the reaction in 1 step itself, COOH. Again, for those who did not get it, when we did partial hydrolysis, these are easy tricks I'm telling you. These are not mechanisms. Please not confuse them for mechanisms. These are tricks that I'm teaching you to remember how to form the product, right? And so this you added one molecule of water and you got CONH2, right? Now, next step, complete hydrolysis means again I break it here, H and OH. So you see over here, this becomes COOH and we get over here benzoic acid. So if you notice over here, this is a very, very important step to convert haloarenes to a number of compounds. Let's go through them. So we started with a haloarene. So I'm taking the example of, let's say, chlorobenzene. Again, we're going to stick to that so it remains embedded in our mind. How do I convert it into phenol? So first with aqueous NaOH followed by hydrolysis. How do I convert it into aniline? By treating it with aqueous ammonia, copper oxide, and I have NH2 over here, right? Then how do I convert it into benzonitrile? I will treat it with anhydrous copper cyanide. Carry out its reduction and we have CH2NH2. Carry out its partial hydrolysis, CONH2. What do we get? Benzamide. you can write the name of the product below the, so you will have CONH2, benzamide. By the way, did you find out the name of this product, CH2NH2? Yes, in the common system it will be called as benzylamine. Then you've got benzamide, and finally the product of complete hydrolysis is benzoic acid. So with this, your conversions also become so easy, right? Correct? Interesting. By the way, how will you name this compound? So this will be cyanobenzene, right? Or benzonitrile. I'm going to explain to you the fundamental of this benzyl, benzo, and benzal and benzo in the next video. For now, I hope you have completed this flowchart of yours. There you go. For today's lesson, we are done with this part of the flowchart. Now for you, the task for you to do is to complete this flowchart so that you have it available as a ready reference whenever you need to. Try reading through it twice a day, probably at your meal times. Don't sit and memorize it like a parrot. Just, glance through it, glance through especially the conditions of the reaction, and you will be done. By the third day, you will be able to write the reactions. But if you want to be able to write the reactions confidently, and when I am saying write, then boss, you need pen and paper. There is no other alternative. So make sure that you practice your reactions as frequently as you can in order to gain confidence in the topic. Haloarenes is not yet done, because if you notice in the master flowchart, we are yet to do with the reduction and what we called as some of the miscellaneous reactions. So please stay connected, stay happy, stay safe. See you in the next video.